Okay, so this section in the textbook should hopefully be reviewed from college algebra or algebra 2. So there's a couple of forms, couple of things we need to worry about here. So one thing is, how do you write quadratic equations? There's two basic forms. You write in standard form, where it's all expanded out and in descending order, or you can write them in vertex form. That's where you can pick the vertex, and what you're going to know here is this is very much like what we did with absolute value functions. The HK is the vertex, coordinate of the vertex. The X of the vertex, the Y of the vertex. That's the vertical stretch factor. The other way you can write them is in factored form. I guess I didn't grab a copy of that, but if you have a quadratic equation, writing it out in factored form also gives us a lot of information. Okay, because then we can see the zeros very easily. Let's see, what else I got to talk about? To find the vertex while you're still not in a calculus class, the only way we know how to find a vertex aside from graphing it is to take the b from your standard form, change the sign, divide it by 2 times whatever that leading coefficient is, and that'll tell you the x coordinate of the vertex, which is what goes right there. If you have to find the y coordinate of the vertex, you just take that value and you evaluate it. So if you have in either form, whichever form you have, it's probably you'll have it in this expanded form, this standard form. You're going to take that x, drop it in, and evaluate your function, and that'll be the y coordinate of your vertex. You write that as a point. If they want you to write it in vertex form, you can do that. That a is nice because that stretch factor stays the same no matter what form you have. Okay, so maybe we ought to take a look at a couple. So these are the try it nows from the book. I'm going to try to do a little bit more with this, just to make sure you see all the elements I'm going to expect you to know. Well, to write g of x in a standard form, we have to rewrite that in descending order. So I'm going to write that as x squared minus 8x plus 7. Now, if we have to solve this equation, the easiest thing when you're solving a quadratic equation, you want to know when it crosses the x-axis, so y equals 0. So you write, whenever you're solving a quadratic equation, we went into this already, this course, you set it equal to 0, and then you try to factor it. This one factors very nicely. So I'm asking myself, what gives me x squared? Well, x and x. What gives me positive 7 that will add to give me negative 8? Well, because I've got a positive 7, both have to be negative, and negative 7x minus 1x is negative 8x. So those are the factors. So then I know the x-intercept is 1, and I could write that as a ordered pair, 0, and 7, 0. So that's where this equation crosses the x-axis. Now, if it doesn't factor, you learned about completing the square. You learned about using the quadratic formula. Remember, the quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. My opinion of this is, a pre-calculus student, you shouldn't have to walk through this formula. So try to factor it, because factoring it's very easy. If you can't get a factor, use some quadratic equation solver. There's plenty out there. If you have a TI calculator, I can point you with a graph link. I can point you to that. It even also isn't too hard to write one. There's also a ton of web applets that'll do this. I showed one in the forum. So, write this and then just use an applet to solve it. Okay. Let's see. Then I guess what we ought to do is, let's see. Let's try to answer this question, and then we'll actually find the vertex. Okay, so how can I answer this question without doing any algebra? Well, I know that this function, because that leading term is positive 1 or positive, I know this parabola opens up, and it has an ending behavior like that, because it is a parabola. It opens up. So that tells me that vertex is going to be a minimum value. For this next one, even though it's not expanded all out, I can see that the a term is negative, which tells me that parabola is going to open down which tells me the vertex is going to be a maximum. So that's how you can do a lot of work without even doing any work. So now let's suppose I need to find the vertex. Well, if you take a look at the B, let's do B first, since that's written so in that vertex form. The one issue with part B is it's 3 minus x. So we could rewrite that as negative x minus 3 squared plus 2. Now, this reversal means that it's been reflected around the y-axis. However, since these parabolas are symmetric, it doesn't, that reflection doesn't really matter, and I'll show you why algebraically in a second here. But if you look at this is the equation that we were given, and here's the graph of it. If we look at another form of that, where I just ignored that horizontal reflection, it gives the exact same graph. So for parabolas, we don't really need to worry about that. Same thing with absolute value graphs. And so algebraically, what happens to that extra negative? Well, if you think about, if I'm squaring a product, I can think of that order of operations says I can square each of those separately. Right? It's the same as AB squared is the same as A squared times B squared, right? So what's going to happen is that negative just cancels out of there and we can get rid of it. What is the vertex of part B, g of x? Well, it's just going to be 3, 2. And notice that's the h. Right, that's the h and that's the k. So that's the vertex. What else? I guess we don't need to answer anything else there. So, and I know that that's going to be a maximum value because this parabola opens down because that leading coefficient is negative. And if you look at the graph I just showed you, if you scroll back, it was a maximum. Okay, how do we find the vertex for part A? So if we think about negative b, x equals negative b over 2a. So the b is 8, so negative 8 turns to positive 8. And 2 times a is 1, right? Because there's a 1, so here's a, here's b, here's c. So that's going to be 4. Then to find the y-coordinate, we're going to find g of 4. So that's going to be 16, because 4 squared, minus 8 times 4 is 32, plus 7, so that's negative 16, plus 7 is going to be negative 9. So the coordinates of the vertex are 4 and negative 9. Alrighty, and that we know is going to be a minimum because this parabola opens up because that leading term is positive. So let's see, we've solved a quadratic equation by factoring or by quadratic formula. We found the vertex. We know whether it opens up or down, and we know whether the vertex is a minimum or maximum. I think that's about it. Now let's go move it on to an application problem. So in that first exam, I'm going to ask you a question similar to this. That's why I figured I'd walk you through one. Make sure you do them. So it is a parabola. I know that it opens down because that leading term is negative. It's in standard form. So at what height was the rocket launched? Well, that is the y-intercept, right? So we want to know at time 0, how high is it? So all we're going to do is find h of 0. So if we substitute that in, all that's left is the 234. So that tells me at time 0 it was 234 meters above sea level. How high above the sea level does the rocket reach its peak? Well, that's the vertex. So we're going to, first off, we'll find t instead of x. Negative b over 2a, so b is the 229. The a is the negative 4.9. So negative 229 over 2 times negative 4.9, and that is definitely a calculator question. So I'm getting 23.367. I go 3 decimal places because since we do have some dual enrolled students, and you guys are going to be looking at taking the AP Calc test next year, they want you to use 3 decimal places. My open math might say something differently, so you just got to pay attention to that. So that's how many seconds after launch it's at its maximum height, and then we're going to evaluate. We're going to find h of 23.367. So I'm just going to use a calculator and crunch that in. So I just wanted to also point out to you, if you do have a graphing calculator, and many of you probably do, you can save yourself a lot of work on the calculator and do that division first. So that's where I've got that answer. But then over the negative symbol at the bottom, it's the key that looks like this. It has the negative sign. It's how you change the sign of a value. There's an answer, an ANS key. So if you do, you can, instead of writing t or x, you can just use that as a variable, and that'll take that last calculated answer and evaluate it for you. So you don't have to type that in so many times. So that's how high the rocket reaches. 29. Does it say? Does it want? Let's see. So I guess so at. What is that? Am I saying it? 23.367 seconds. That rocket is 2909.561 meters high. So that the answer is B. So what we have to worry about for part C is what time does the rocket splash down? Well, if at time 0 it's that high and this parabola opens down, I know that is going to be the splashdown point, and I also know that is another answer for this quadratic equation, because what we're really doing is, where does h of t equal 0? Now, we certainly don't want to try to factor that, so this is a perfect time to use a quadratic formula app. And what you're going to know is that a is negative 4.9, b is 229, c is 234, and now you can go use the quadratic equation solver of your choice and get the answer. So the one I used just gave me negative 1.000 and 47.735. So obviously I can't have negative time, so that's an extraneous root. We won't even consider that. So that is the time, 47.7375 seconds after launch. Okay. I just realized my graph here isn't that good. I should have really gone more like this to have the parabola have the peak. The peak should have been more like this. And that even doesn't look like a parabola, does it? We'll make a smushy one. So that looks better. There's my peak. So that is the time the rocket splashes down. Now, while I'm on this point too, one thing I'm going to ask you to do on the exam is you're going to have to say that, okay, so when is this rocket at 300 feet up, say? So, and I'm going to have you graph that, illustrate it on a graph, and solve it. So to illustrate it on a graph, since I know this is the 234, I know 300 is going to be about there, y equals 300. So it's going to be at 300 feet 2 different times because it goes up higher, right? Solve it. Basically what you're doing is you're saying, when does h of t equal 300? And that'll give you another quadratic equation. You'll say 300 equals negative 4.9t squared plus 229t plus 234. You'll subtract this 300, use a quadratic equation solver, and you'll get 2 answers. And you'll get the 2 answers, right? Because there should be 2 times where it's 300 feet up. Okay, so I hope that helps you do the questions in this section.